we think that we should use the past patterns of diffusion, as we call it, of gradual adoption of general purpose technologies as the starting point for our understanding of AI. So I do think that successful AI diffusion requires a greater culture of experimentation than many companies are perhaps used to. I think companies should try to find an optimal balance between bottom-up and top-down kinds of experimentation. I think companies are used to thinking about automation that usually proceeds in a top-down way. And that's not something you can do in a top-down way. That's when we're more likely to call it AI. But when it actually becomes socially integrated, we take it for granted. It just becomes a part of our digital or physical environment, and we stop calling it AI at that point.
皆さんこんにちは。NTT データ経営研究所グローバルビジネス推進センターの J と申します。本日はプリンストン大学のアービンド・ナラヤナン教授と対談を行います。ナラヤナン教授はプリンストン大学のコンピューターサイエンス学部の教授であり、同大学の情報技術政策センターのディレクターを務めていらっしゃいます。ブロックチェーンや AI など最先端のデジタル技術が社会的にどのような影響を与えるかに関する研究で世界的に知られております。また AI に関する誤解を正すプロジェクト AI スネークオイの共同著者でも知られており、AI の可能性やリスクの議論を世界的にリードしています。その功績が評価され、TIME誌100 AI にも選出されています。本日の対談は、教授の最新の論文 AI as Normal Technology を中心に、AI が電気やインターネットのように世界的に浸透いくプロセスや、それがビジネスや社会的にどのような意味を持つのかについて議論いたします。本日の対談を通じて皆さんに有意義な示唆をお届けできることを願っております。よろしくお願いいたします。
Good morning, everyone, and good evening for Professor. My name is Han from NTT Data Institute of Management Consulting, and with me here today we also have Jay from my team. And Jay and I will be the hosts for today's dialogue with Professor Arvind Narayanan today. And for today, the dialogue will be centered around his article on AI as normal technology. And we'll be going through some of the core ideas that he introduced in the AI as normal technology article. We'll be also talking about AI in business and in Japanese context. And in the end, we'll also talk about the societal impact of AI as well. And hopefully by the end of the dialogue, our viewers will have some more clarity on their AI strategy and what to do in this very uncertain environment. So welcome, Professor, and it's great to have you. So before we start, I would maybe like to talk a bit about your journey up until now. So you obviously have a very strong background in computer science, and your work spanned from data privacy to platform transparency to blockchain technology and so on. And in recent years, you have also co-authored AI Snake Oil and AI as normal technology as well. And this has put you in the center of the AI conversation now. So could you maybe give our audience a brief self-introduction and share what led you to your recent work, including the AI as normal technology article and AI Snake Oil?
Sure. It's great to be talking to you, Han and Ajay. The broad theme of a lot of my work is that technology can be a force for great good in society. However, the technology industry, technology companies, they have their own interests, which are not necessarily fully aligned with the interests of the public, with the interests of society at large. And I have always felt that computer science researchers and other researchers, but certainly computer science researchers who have the technical skills and expertise to understand leading edge technologies like AI can play a role in identifying the ways in which companies' priorities are diverging from the public interest and try to bring them back closer together. So one way in which I have done that is I led a team looking at privacy on our devices the ways in which all our apps and websites are full of hidden trackers that are recording our browsing, shopping, and clicking behavior. And this is used largely for personalized advertising, but it also has a number of other side effects. What does this mean for government surveillance? There are a lot of profound questions around this. So that's the reason I worked in privacy. It's one big area where companies' interests are diverging from the public. And that's the same reason I started to work on AI about 10 years ago as well. Many AI applications can bring great benefits, but it was also clear that very often AI is being used as an excuse to sell whatever it is that companies want to sell, which might not necessarily bring the claimed benefits. And I figured that a lot of research was needed in order to identify the kinds of AI applications that do work and don't work. And in the book AI Snake Oil, co-authored with Sayash Kapoor, we tried to give readers a way to figure out for themselves. It's not so much us telling them what works and what doesn't, but give everybody an understanding so that when they hear a new pitch for AI software that can revolutionize the workplace or your relationships or whatever it is, they will be better equipped to evaluate those claims. Now, AI Snake Oil was about some of the dubious claims about AI that are happening today. And AI as normal technology is about thinking through what maybe the next 20 years could look like. So it's a much more forward-thinking piece.
All right. Thank you so much, Professor. So before diving deep into the dialogue, let us align on one of the core concepts that you have introduced in your recent paper, AI as normal technology. You call AI as normal, and probably you received a lot of reactions on this piece, and probably some misunderstandings as well. So normal could have two interpretations. One could be decoupling AI from the hype, have more clarity on the technology and its impact. And the other could be seen as downplaying the impact. So the question to you is, why did you choose this word normal? And what do you mean when you say that AI is a normal technology?
Thank you. We are not downplaying the impact. And if one reads the essay, this is very clear. In the second sentence, if I recall correctly, we compared AI to other profound technologies such as electricity and the internet. However, what we mean by normal, exactly based on comparisons to other past general purpose technologies, is that there are well understood patterns of the way in which technology gets adopted, the way in which it impacts society, impacts workplaces. We felt that a lot of the current discourse around AI is happening without people being aware of that long existing research and are treating AI as if it is a technology for which all the rules have to be rethought from scratch. We don't think that's the case. We think that we should use the past patterns of diffusion, as we call it, of gradual adoption of general purpose technologies as the starting point for our understanding of AI. Now, no two technologies are exactly the same. Of course, there are some differences when it comes to AI. We should be attuned to those differences. We should look for evidence of ways in which AI specifically differs. However, we should start with an understanding of history. And that is the core point behind the essay.
Thank you. And just a quick follow-up question to that. So do you also see AI as a normal technology across all levels? So for example, for individuals, organization, and society, for example, or like is there like a context where this framing doesn't really apply?
The context where we've done the most amount of work in thinking about the implications of AI as normal technology is in the workplace and the economy at large. AI, of course, is being used by everyday individuals in their daily lives. And I think in different contexts, it can be more, the effects can be more predictable or less predictable. In fact, at a societal level, to us, part of what it means to be a normal technology, to be a general purpose technology, is that some of these societal effects actually can be unpredictable. We've seen that with cars, we've seen that with social media, we've seen that with many past general purpose technologies. So for instance, in the early days of cars, people were very worried about the risks in terms of the speed of cars, accidents, and so forth. And those turned out to be real risks. But some of the consequences that nobody was really thinking about in the early days is what would this do to the character of cities? So in countries like the United States, compared to countries like Japan, for instance, the character of cities has tremendously changed because of the rise of suburbia, which was enabled by the rise of the automobile, and we don't have strong transit systems, dense urban cores in the way that many other countries have. So these are examples of what we call emergent effects. Emergent effects are not a property of the technology itself. It's a property of how society, policymakers, institutions all decide to react to the technology, to adopt the technology. And that future is not written yet. And we shouldn't pretend that we can predict what these emergent societal effects are going to be. And we have to remember that we collectively have the agency to shape this future. Whereas when it comes to the workplace, I do think there are relatively more well-established patterns. There is perhaps a greater degree of predictability, although, of course, the aspect of agency is very important. We can shape how different companies are going to deploy AI and what the relationship between workers and firms is going to be as a result of this technology and so forth.
Thank you. So the next question we have for you is a bit related to, this is something that you have had a lot of podcasts and interviews on already, so we will not dive too deep into the kind of like the details of it. But for our viewers, there's another narrative about AI that's very different from your AI as normal technology. This is a more rapid transformative change with superintelligence, as mentioned in an example of AI 2027. And as mentioned, this is quite a big contrast to your more gradual and institutional change from your paper. And for business leaders, this can be quite confusing. It almost feels like they are kind of like forced to pick a side to have their AI plan in the future, for example. And this really hinders the speed of their AI strategy as well, especially in the context of in Japan, where the culture here tends to be a bit more conservative and we tend to avoid risk as well. So my question to you is that, are these two kind of viewpoint really conflicting views, and are there any common grounds regardless of the narratives?
Thank you. Definitely, we're not exactly on the same page as the AI 2027 authors. There are serious differences in our expectations of how the future will unfold. And of course, in their view, within a few years, superintelligence is going to potentially make human labor superfluous, raise the possibility of catastrophic risks, and so forth. Our view, as you said, is more longer term and centered on institutions. Nonetheless, even in our view, organizations should have a certain degree of urgency in responding to this moment. So one thing we emphasize a lot is that capabilities might advance rapidly, and AI capabilities are advancing rapidly, but that to translate them through impact requires going through all these stages of going from invention to innovation to early adoption to diffusion. In some sense, if you believe that normal technology view, that should create more urgency, not less, because there is so much work to do. Because there are already all of these AI capabilities whose benefits we are not yet reaping in the workforce because we haven't done that hard work of going through these various stages of technology adoption. We haven't done the work of thinking about how should we change our workflows to take advantage of this while avoiding the risks and pitfalls of AI, which norms and laws and organizational practices need to change, which revenue models need to change. So in that sense, I very much agree with the need for urgent action. But it's just a difference in terms of what kinds of actions are most necessary. Are they actions relating to the technology, or are they actions relating to institutions?
Thank you. And you mentioned the need of urgency. So the next question is for organizations, what are some of the things that they can do today, regardless of how the future of AI may turns out to be? This might be a bit vague for you to answer, but if you can provide our viewers with some ideas or like some direction, that would be very nice.
Yeah, and I will just kind of reiterate the thing that I already said. I mean, when I look at myself, for instance, as a user of generative AI, I know that even to use the capabilities that are currently available, but in a productive way, I have to do years of work to adapt my workflows. So, for instance, I do a lot of research, and there are these new AI agentic tools, as they're often called, that can really help me find lots of obscure information online that can be really helpful in the process of doing my research. But I also know that there can be subtle mistakes in the work that these AI agents do. So if I'm going to use them in any meaningful way, I need to develop workflows so that I can efficiently verify their work so that I'm improving my productivity while avoiding mistakes, and also somehow ensure that my own research skills don't degrade over time, that I'm actually exercising my critical thinking skills, right? So these are things I'm working on every day to try to figure it out. I know that the capabilities are there. I'm not confident that I've sufficiently adapted my own workflow in order to take advantage of this. And I'm speaking as someone who's an AI researcher, and so I can spend a tremendous amount of time, maybe 10% of my time, experimenting and playing with these AI tools to adapt my workflows. And that's just one use case, research. If you think of a large and complex organization with 10,000 workers in many different roles, and their priorities are not related to AI, they have to get their jobs done every day. Organizations need to do so much work to give those workers the freedom, the time, the permission to make mistakes, to be able to experiment with these new capabilities, develop new workflows, share them within the organization, and gradually change practices. So there's a lot of work to do.
So let's go a bit deeper into the article. I think you have a very interesting analogy comparing AI to general purpose technologies such as electricity or internet. There are two terms of progressions that we see. So electricity, it started from lighting companies, industries adopted it, households adopted it, and then it's widespread in the society. Similarly, for internet, we see that there were research companies, there were platform business models that came up, and now internet is everywhere. However, with generative AI, we see a different kind of progression. We see a mass adoption by consumers first, and now we also see organizations chasing this technology. So how to reconcile these two different patterns of diffusion of general purpose technology using the stages of general purpose technology that you have in the paper?
Sure. I think the key thing here is to keep in mind that adoption of generative AI doesn't mean one single thing. It can mean many things. Most people who are showing up as generative AI users in the adoption statistics are not really using them in a deep way. And there's a powerful statistic to drive this home. OpenAI itself revealed that as of a couple of months ago, among all ChatGPT users, less than 1% were using the so-called thinking or reasoning models, which take a longer time to produce an answer and do higher quality work in many cases, right? And so it might be true that these generative AI platforms have, a billion users who use it on a weekly basis, but are they using it in a deep and meaningful way? Or are they using it, once a week to tell a joke or something? I suspect that for the vast majority of users, it's the latter. So we really aren't, we're still in the early stages of people figuring out deep and meaningful adoption. So that's one caveat that I want to make. I think what we're seeing with generative AI is not any kind of exception to the stages of general purpose technology. It's very much an example of it. And let me explain why. So the first two stages are invention and innovation. So we put the development of large language models in the invention stage and the development of various products around large language models, such as chatbots. People often think of these as interchangeable, but they're really quite different. We put that in the innovation stage, and we explain in the paper why we do that. So to really drive home that invention is not the same as innovation, many companies thought that you could take these underlying large language models and put simple wrappers around them and create new personal assistants for people that would be voice activated and would work without any kind of display or screens. So unlike a smartphone, this would kind of be like a Siri or Alexa that just sits in your pocket. You could talk to it and it would go and do things for you. There have been a few products like this that have been released, at least in the United States. I don't know how widely internationally they were released. They had names like the Humane AI Pin and the Rabbit M1, I think it was called, a few other assistants. Now, what happened was it turned out that these companies did not do the hard work of developing and testing products. How well do they work in these screenless environments? Are they working reliably? Are they working 90% of the time, or are they working 99.9% of the time? It turned out they worked 90% of the time or 80% of the time. So you could do very cool things with these products, like ask it to purchase something online, it would buy it for you, and it would get shipped to your home. That's pretty amazing, right? The capability here is really remarkable, but the reliability was not there. So, 10% of the time it might send your product to the wrong address, right? And now you've lost money. And so nobody wanted to use this kind of product. They failed miserably in the market. So that's an example of how it might seem like there's rapid adoption, but when you look at a person really trying to integrate it into their everyday life and rely upon it, that's when a lot of barriers arise. And we're only gradually figuring out how to overcome those barriers. And that's the second stage, the product stage. And then there's the adoption and diffusion stages, which, especially in a work context, require even more changes and tend to happen very, very gradually.
Understood. So maybe staged progress from invention, innovation, adoption, and diffusion is the way to kind of cut the noise and see how actually we are doing in terms of generative AI adoption, right?
So this stages of general purpose technology approach has been very useful for us to analyze what is happening with AI and generative AI in particular. I think viewers should maybe read our essay and decide for themselves whether or not they find this useful for their specific purposes.
Thank you. And for the next part, I think one of the takeaway that I got from the article is, like, as you mentioned, like, we already kind of have the capability with, like, the new LLMs and whatnot. And in your article, you mentioned that diffusion is most often the bottleneck for the normalization of AI. And despite all the pilots and POC and the products like the Rabbit M1 and the Humane Pin that you mentioned, only diffusion can truly like produce a sustained business impact. Can you explain to our viewers why is that the case?
Sure. Let me give you a historical analogy. And this is an analysis of what happened in, I think, what is called the Second Industrial Revolution, when electricity started to become a very useful technology in factories. So at first, they didn't figure out the diffusion stage. What factory owners tried to do is replace their big steam boilers with electric generators. That didn't really help. It didn't result in any cost savings. So they thought, this technology is not very relevant for us. But it took many decades, if I remember correctly, it took 40 years for people to figure out the right way to diffuse electricity into factories. And the answer turned out to be to take advantage of the fact that electricity, unlike steam power, is a much more portable and mobile kind of technology. And so instead of generating it in one place and then mechanically moving power throughout the factory, the solution was to generate or move electricity wherever it was needed and to have many small machines doing various things. So that required reorganizing the factory around the logic of the assembly line. And that required training workers differently. It required changing the relationship between the worker and the firm. So all of this took a very long period of time. And we think that when we look at specific industries, a very similar thing is starting to happen with AI. So if you look at software engineering, for instance, so the use of AI to generate to help produce software, which is one of the areas where adoption has been, relatively speaking, very, very fast. Even there, software engineers are in the very early stages of figuring out how best to change their workflows in order to incorporate this technology. Only in the last few months have software engineers invented new ideas like context engineering, which is a way of adapting software engineering to the limitations of large language models. And now they're thinking about how should pricing models for software change given some of the capabilities and limitations of this new way of producing software. So I think those are all the things that are going to produce real value. In contrast, when software engineers have tried things like vibe coding, which is just to describe in a prompt what you want the large language model to do and rely on the large language model to produce a simple software application for you. It works sometimes, and it seems like you've saved a lot of money by producing the software really fast. But then a bug arises and you haven't written the code, so as the software engineer, you don't know how to fix it, and you recognize that there are lots of costs down the line. So over and over again, we see in many industries that when companies deploy too quickly without really changing their workflows, guardrails, business models, they find out after, weeks, months, years that there are costs that they were not thinking of in advance.
Thank you. So as you mentioned, like different industry perhaps need different kind of reorganization within the company to be able to diffuse AI, right? So some might need a workflow redesign, as you mentioned in the factory example, and some might require some, like, for example, giving some bandwidth to the employees to allow them to get familiar with AI and so on. And I think one more issue that I think business leaders are slightly more concerned is, like, for example, when they're doing a pilot or like a POC in one business unit, what are some of the ways that they can reliably transfer this success from one business unit to the whole organization? Are there any ways that business leaders can reliably do that?
Sure. If I understand the question correctly, it's how to transfer a proof of concept from one business unit to many others within the organization.
Yes.
One thing to keep in mind is that AI is a little bit different from traditional software. If we're talking about some sort of productivity software, let's say Microsoft Office or anything else that we might use for word processing, we can learn pretty well from the experiences of other teams. Did it save you time? What are some of the tips and tricks? How do you collaborate using this software? I think certainly we can, with AI as well, we can learn from POCs and other units, but it's a little bit more challenging because the performance of AI might differ dramatically based on the specific use cases, the specific kinds of data inputs that people give, and many other factors that we might not think about ahead of time. So I do think that successful AI diffusion requires a greater culture of experimentation than many companies are perhaps used to. So there needs to be a constant process of experimenting to find new use cases, piloting those use cases, starting to deploy those use cases, but then a practice of regular auditing and monitoring, because something might work this year, it might actually work less well next year because something about your data inputs has changed or something like that, right? So there needs to be much more of a process of evaluation that's integrated into the process of deployment.
So I think one thing that I got away from the stages of general purpose technology evolution is that different companies might be working in different stages. It takes a village to raise a child, and probably different companies in a particular industry would drive technologies such as AI from invention all the way to diffusion. We already have big techs working towards the fundamental models. We have leading startups working towards innovation. We also have companies like OpenAI, which are working, having their own fundamental models, tools, and recently they started their consulting services as well. So how should companies position themselves into this different stages of evolution to do what they do best, but also partner with others when it's needed?
Let me make a couple of points in response to this. One is, as you see in the chart that you have just shown, there are arrows from innovation to diffusion, but then back from diffusion to innovation. I think this is super critical to keep in mind. In the last few years, we had the development of more and more capable chatbots simply by training on bigger and bigger sets of scraped data from the internet. But the ability of that approach is pretty limited. It has enabled these chatbots to provide really good answers to questions. But when it comes to taking it to the next level, building agentic systems that can do things online for you, automate workflows, this approach of simply training on scraped text doesn't work that well. And that's where this innovation diffusion feedback loop really comes in. It is only by deploying these systems, especially these agentic systems, in real world contexts that you can gain the data sets and experience that is necessary in order to continue to further improve the software. And this kind of feedback loop has played out in many sectors in the past. So when it comes to self-driving cars, for instance, companies had to build early prototypes of self-driving cars that could drive for, let's say, 100 miles or 100 kilometers and get enough data to improve the accuracy so that they were confident enough to drive at 1,000 kilometers in real world conditions, and then move up to 10,000, a million, and so forth. So that kind of feedback loop, I suspect, needs to happen in every sector. And there is an important role for every company there. And so the way to think about partnerships is that if you're a deployer of AI, through the process of diffusion, you're bringing something that's incredibly valuable to someone who is doing the innovation in your particular sector. That might be a different unit in your company, or it might be another company. So if you're a law firm, then you have something incredibly valuable. The real world experience of using legal AI products in all of the use cases you've used them, that's very valuable to companies developing new legal technology. So partnerships that can help complete the innovation diffusion feedback loop are going to be incredibly valuable.
Understood. Thank you for the insight. So maybe not just what you are doing, but also focusing on the loop, what you have, empowering others, and also building upon experiences and expertise of others would be critical. Thank you so much. All right, in this section, we want to first talk about the AI impact in business and also touch a bit upon the AI impact in Japanese businesses. So we saw the productivity paradox in 1970s, 80s, which showed that increased AI IT investment does not necessarily mean measured productivity gains. This might be a case with AI as well. So the question to you is, how should business leaders measure the success with AI, and what should be their yardstick if not productivity gains?
Sure. I think perhaps one reason for the paradox is that productivity is often measured based on a particular task. So the use of AI, makes this particular task, let's say, 5 times more productive, right? A worker can produce 5 times as many units of this task in a unit of time as they could have without the help of AI. The problem with that is that that particular task might be only one of many things that the worker needs to do. So a famous example of a mistaken prediction based on this misunderstanding was Jeff Hinton, recently a Nobel Prize winner, but back in 2016, he's a leader. He's long been a leader in AI technology, and he made the prediction that given that already in 2016, AI, specifically computer vision models, were rapidly getting better at looking at radiological imaging and then predicting, is it a cancerous tumor or not, that sort of thing. He thought that radiologists would soon be obsolete. And he said, of course, the medical system should stop training radiologists. There are going to be no jobs for them. This led to a lot of panic in healthcare. But it actually turned out that the employment of radiologists has significantly gone up since then. And this is not because the medical system is rejecting the technology. They have, in fact, enthusiastically embraced the technology. But it turns out that reading these scans, which outsiders might think of as the main thing that radiologists do, is in fact only one of 27 different things that they do. And that's specifically according to the ONET database, which is a database that economists often use to study the productivity of different kinds of workers. Right, so that's one reason for, perhaps, I'm guessing, for productivity paradoxes, forgetting that jobs are actually bundles of many different tasks, and looking at it at a task by task level is not that helpful. I think, in addition to looking at the impact on an entire job and not just one particular task, what businesses should be doing is looking at what is the impact of AI adoption on workers' subjective experiences of how fun the job is or not fun. These are things that are hard to measure, but unless you make an effort to take them into account, it might be that it appears that you're improving productivity, but workers are getting burned out, and within a year, maybe most of your workers have quit. That would not be a good situation. Or is it helping workers improve their skills over time, or are workers' skills degrading over time? So if it turns out that productivity improvements are coming at the expense of degrading skills, essentially what is happening is that the firm is capturing some of the short-term productivity benefits, but the worker is paying a long-time cost because their skills are degrading and they're going to be less employable at another firm in the future. And of course, workers are going to recognize this, and then there's going to be a backlash against AI adoption. And this is not to say that I'm pointing out a lot of negatives in terms of the ways in which firms might be over optimistic about estimating productivity gains from AI. I don't mean to sound one-sided. I do mean to say that they should consider a lot of these factors, and based on that, sometimes maybe there's a reason to be deploying more AI than we might otherwise think, because maybe there are no productivity gains today, but it turns out that gradually it's making workers more skilled because of the specific AI technology that's augmenting workers' abilities instead of replacing their abilities, right? So my only point is that we should think about this in a more holistic long-term sense as opposed to a narrow short-term productivity measure.
All right, thank you so much. So not looking at it narrowly, not looking at tasks as themselves, but looking at jobs and also having a long-term vision of AI. Thank you so much.
And right now we are seeing a lot of investment and crazy evaluation in AI-related company, and we are also seeing a lot of investment from companies into the AI pilots and so on, right? However, not many of these pilots actually kind of yield meaningful business revenues and so on. So from your viewpoint, what are the most common maybe challenges or bottlenecks that companies might be facing in the very early stage of integrating AI into their pilots or into their workflow? And are there any domains or industry that may be facing more barriers than the others?
Sure. Let me maybe mention a couple of challenges. One of them is that when AI makes mistakes, it's not clear who faces liability. And unless that's worked out, there are going to be a lot of uncertainties that make companies hesitant to deploy AI. There was a famous case of a chatbot. Now, I have to say, 3 years ago when ChatGPT came out, I thought customer service chatbots would be one of the first things to get automated. I mean, chatbot, it's right there in the name. But when companies started trying to do this, they started to discover barriers. So in this case of an Air Canada chatbot, of course, generative AI can make mistakes. This bot made up a non-existent refund policy, and the customer was wronged as a result of that. There was a lawsuit. It went all the way to the Canadian Supreme Court, and the court forced the airline to uphold this non-existent refund policy, right? So that's a kind of cost that that took many years to materialize. But once companies started recognizing these costs, they became much more careful. Klarna is a company that offers small loans to shoppers, and Klarna had said that it was getting rid of their customer service people and replacing them with AI. But a year after that experiment, it actually hired back many of those customer service workers. So one common challenge is figuring out liability, properly accounting for costs. And one innovation in response to this is insurance for AI mistakes. So if insurance becomes much more common, then it might give companies more confidence in going forward with these deployments. Another challenge is that customers, again, sticking with the customer service example, customers might not like the experience of talking to AI as opposed to a human. It might also be the other way around. Customers might prefer the experience of interacting with AI. It might be faster, etc. So again, that's another thing that you can only find out through deployment. It's hard to measure without customers actually experiencing what that interaction is going to be like. Are there domains that face more barriers than others? For sure. One domain that faces a lot of barriers are cultural industries where many people feel that automation would be missing the point of what that industry is all about. So, sorry for the US focus, that's where a lot of the examples in the news that I follow come from. But when it comes to Hollywood, for instance, when it comes to AI adoption in the movie industry, there has been tremendous pushback from writers, actors, other creative workers in Hollywood who feel that AI generated scripts or imagery would be kind of soulless and is losing the art involved in filmmaking. Even if from a pure entertainment business perspective, it might lead to an acceptable product. And so there has been resistance, tremendous resistance to the use of AI in that context.
Thank you. So you mentioned about some industries like more like the cultural side might face more barriers in deploying AI and so on. And one thing that we are seeing here in Japan is like we have a lot of world leading companies. However, many of these are from the asset heavy industries. So companies like in the manufacturing or like in the car business and so on, right? And these industry, they tend to face more barriers when like transforming, not just for AI, but for like the normal digital transformation as well, because in this industry they tend to have lower tolerance for errors, and they also have lower scale and scope of data. So data are harder to come by, it's harder to get real consumer data and so on, right? So these are typically more of the B2B companies. So how do these limitations affect the normal kind of like the normal technology chain, and how should asset heavy companies think about their AI strategy to not be constrained by these limitations?
Definitely. So I'm going to speak to this as a computer scientist, which is, after all, ultimately what I am. And I spent most of my time thinking about really the technical nitty-gritty of all this. So I would say that in areas with low tolerance for errors, it makes a huge difference which kind of AI you're deploying. We've been talking about generative AI a lot and agentic AI, and I know that these tend to get most of the media coverage. But really, those are only some categories of AI. There are more special purpose AI technologies, a lot of which do involve machine learning, although more traditional, kind of more reliable types of machine learning, but many of which don't even necessarily involve machine learning at all. And when we say AI, it's an umbrella term that refers to a whole lot of different technologies. And so I think companies with low tolerance for errors should be looking at other kinds of AI. But even to the extent that they are looking at generative AI, there's a lot of research on things called verifiers. So these are things where you have an unreliable generative AI-based system proposing a solution, but then you have a verifier, which is a more deterministic, traditional kind of software that's checking the solution produced by generative AI. So these kinds of configurations can produce dramatically lower error rates compared to, simply a large language model generating a solution. Another way to use unreliable AI technologies in industries where high reliability is required is to use AI to check the outputs of human workers and try to flag any potential errors that humans may have made. And here, it's okay if the AI is unreliable because maybe it will miss some mistakes, and that's okay. You would have missed those mistakes if you hadn't used any AI in the first place, so it's not any worse. And maybe it might flag some things as errors, but they're not actually errors, and that's okay too, because ultimately another human is going to review it and check if it's actually an error or not. So when we drill down into the specifics of the technology, I do think there are many ways to use AI even in these kinds of industries as well. And finally, when it comes to the lower scope of data, again, there are many options. There's a lot of exciting research happening that looks at, can you take a little bit of real data and generate a lot of synthetic data out of it? Can that be a way forward? And there's research happening on what is called sample efficiency. So traditional machine learning requires a large number of samples or examples that you give the machine in order for it to learn. Can we have new kinds of learning algorithms that require many fewer samples to learn, perhaps using reinforcement learning? So I would say, be on the lookout for technological innovations. This is something that researchers are actively working on.
Thank you for your insights. So you mentioned about industries who might face a slower progression of AI, but they might look into other models of AI which suits them the best. And earlier we also talked about how companies could partner with different companies to kind of accelerate the feedback loop between diffusion and innovation. So the question is that even within the same industry, there might be companies who are going very aggressive or some companies who are going very conservative. Of course, they have to maintain a very delicate balance so as to not overestimate, overcommit, or overinvest in AI and avoid like big embarrassing mistakes, but also being required to not miss the AI adoption too as well by being too conservative. So how should individual companies think about maintaining a sustained path towards a well-managed experimentation, if you could say? Could AI governance within a company be the key to this kind of mindset? What do you think, Professor?
I think companies should try to find an optimal balance between bottom-up and top-down kinds of experimentation. So broadly, I would divide AI applications into automation and augmentation, right? Automation replaces human workers in certain tasks that they might have done. Augmentation helps them to produce better outputs or outputs faster, or extends the scope of what the human worker can do in some way. I think companies are used to thinking about automation that usually proceeds in a top-down way. The, management receiving a pitch from an AI vendor, they might do a pilot, they might look at the data, and they might decide to replace some number of human workers and processes with this automated solution. But I think augmentation requires a radically different approach where you have to give individual workers the freedom to come up with new use cases. Because unlike automation, a big part of the challenge is in figuring out what even are the use cases here. And that's not something you can do in a top-down way. And so if you're going to give people the freedom, then you very much need guardrails and AI governance. You want to make sure that workers are not revealing sensitive data to, AI vendors who shouldn't be getting that data. You want to make sure that workers feel empowered to do this experimentation, even if it might lead to failure. In some cases, they want to know that management will have their back. And finally, one thing I've often heard, and Ethan Malik is someone who's written about this, is that workers often experiment, come up with new workflows that improves their productivity. They don't feel like sharing it with their coworkers because they feel that if that innovation diffuses throughout the organization, they don't individually stand to gain from it. The management is just going to realize they've become more productive and simply give them more work. And so, how do you empower workers to share within the organization and actually reward them and incentivize them for such sharing? So I think these are all aspects of AI governance that are often overlooked. But if companies get them right, they can really foster a culture of bottom-up experimentation, which complements top-down experimentation.
Thank you so much. So maybe guardrails are giving them more freedom to experiment rather than curbing their freedom is a good way to think about it. Thank you so much.
So in this section, we would like to talk a bit more about AI's societal impact. So the diffusion of normal technology doesn't really limit to just companies, right? It also includes how the technology is integrated into our daily life, like how internet is part of our daily life right now. And so despite seeing all these kind of AI apps, so first in ChatGPT, then like Gemini, and recently the Sora 2 apps are like the top most downloaded apps in App Store, for example. However, it's kind of safe to say that AI is not yet being socially integrated. One of the reasons might be the one that you mentioned before, despite the vast number of downloads, these users are not really using them in a meaningful way. And my question to you is what kind of indicators can suggest that AI is being fully socially integrated rather than just technically deployed?
Yeah, definitely. There is an amusing definition of AI that says AI is whatever hasn't been done yet. So what does that mean? AI is whatever hasn't been done yet. What this is referring to is that when a technology is new, when its societal effects are double-edged, like you said, it's not yet socially integrated, but just technically deployed, that's when we're more likely to call it AI. But when it actually becomes socially integrated, we take it for granted. It just becomes a part of our digital or physical environment, and we stop calling it AI at that point. And there are so many examples of this in terms of physical ones. It's things like robotic vacuum cleaners, which at one point was considered AI, but is not anymore. We take it for granted as a kind of gadget we have in our homes. And in the digital space, at one point, even simple things like voice dictation were considered AI, but now we just take it for granted. We don't even really think about it. And I think that's what it means for something to become socially integrated. It becomes part of our environment, part of our lives, our workflows, to the point where we don't need to think about it. Sometimes that's going to be harder than in other cases. So if we look at self-driving cars, we do think this is going to happen. It's gradually happening already. And eventually, most driving will be done in an automated way. And the word car will mean self-driving car, and we'll need a new word, maybe manual car, to describe what we call cars today. And at that point, we can say that it has been socially integrated. However, to get there, we have to figure out how governments are going to compensate people who stand to lose their jobs, such as professional drivers, because of self-driving. They have to figure out how traffic infrastructure on roads are going to have to change. So there are many things to figure out, both from a business and societal and policy perspective. But I do think those things will happen one day. And the last thing I will say is that switching back from the physical to the digital space, I think one of the clearest indicators that this is becoming integrated is that instead of a special app like ChatGPT that we go to in order to do something and then come back to our regular workflow, AI actually becomes part of all the regular apps that we're using throughout our workflows, whether that's your spreadsheet or whether it's Zoom right here in order to have this conversation. I can imagine a future where I'm automatically seeing a transcript right here on the screen of everything that I'm saying, and if I made a mistake, it automatically underlines, that I misspoke and I meant to say something else. So without even my having to think about it and deploy AI is just kind of there in the background, helping me as I do things in my everyday life. And we say in our book, AI Snake Oil, this is exactly what happened with the internet. So 20 years ago, we had to log on to the internet, and back then internet was very expensive. We had to quickly do what we wanted to do and then disconnect and go back to our offline lives. But of course, today, our work lives and much of our personal lives are simply lived online. It's just the medium through which life and work happens. And our hope is that this is what will happen with AI in the future. And that's what it means for me for AI to be socially integrated.
Yep, understood. That's a very clear and I think easy to identify kind of indicator for when AI is socially integrated. Moving on to the next part, I think in Japan we have quite a unique situation. So this might be like something that other countries might face in the future as well. So we have an aging society, we have labor shortage, and more uniquely to Japan, we have some companies, we still have a lifetime employment culture. And so when AI hits, instead of asking, will AI take our jobs like many other countries, some Japanese people are actually asking, can AI fill the critical jobs we don't have enough people for? So I think the mindset is slightly different. And when the same productivity gain might result in different societal reaction. So for example, in Japan, this kind of like increase in like productivity can ease labor shortage problem. But whereas in the US, I'm not an expert in the US, but just an assumption, an increase in like productivity might mean more like layoffs and therefore more like societal pushbacks and so on. So I'm just wondering, can this kind of like maybe like be a driver in like Japan's AI diffusion? And when we are looking at normal technology change, should we and how can we consider this kind of societal impact into our kind of like AI future prediction, if I can say that as well?
Yeah, thank you. And your comment about the US is exactly right. We typically are very concerned from a societal and policy perspective about people finding enough jobs. And so anytime there is a talk of AI and automation, there's always a huge pushback in terms of what this means for workers. And so for that reason, AI diffusion faces many kind of psychological, societal, and also policy barriers. And so, yeah, in a country where labor shortages are the norm, that very much changes the relationship to technology. And I don't know, it's a question for you. Is this one reason why Japan has long been the leader in the adoption of physical robots? And if that's the case, will that also translate to greater diffusion of AI? And perhaps one more advantage in the Japanese context based on the lifetime employment culture is that when a worker is kind of strongly tied to a firm, then it becomes much easier for the firm to invest in the long-term skill growth of that worker, as opposed to thinking about how can we extract the maximum productivity from this worker for the next 6 months or a year, even if it leads to a degradation of their skills, which I know I keep emphasizing that point, but I do think it's a very underappreciated point. And so if there is lifetime employment, I'm just guessing here, perhaps it creates incentives for the firms to really invest in their workers, which leads to a much more healthy kind of AI adoption compared to a country like the US. And the third potential source of advantage is leapfrogging. I am aware that Japan has been slower in many ways in the deployment of information technology, and many processes that have long been digitized in countries like the US are not yet digitized in Japan, and paper is still used. And so leapfrogging is the concept in international development where a country skips one technology generation and goes directly to the next one. And by skipping the generation, it can move faster in many ways in catching up to the newest generation of technology. So maybe by combining digitization and AI adoption, Japan can actually achieve certain benefits in AI diffusion.
Understood. Thank you. And the last question for the societal impact of AI would be when you compare AI to like electricity and internet, I think it's quite clear that each technological era kind of like needs a different capabilities of leaders. So say in the future when AI become a normalized part of our society, what kind of capabilities do you see and do you believe that will be essential for leaders to lead the change in an AI-driven society? So maybe this can be something that is beyond the technical capability or knowledge, things like ethical judgment or like human-centric competencies and so on.
Yes, we have a prediction about this in the AI as normal technology essay. We make a comparison to the Industrial Revolution, which we kind of see as resulting in the automation of most physical labor. So if you take construction, for instance, or agriculture, most of the physical work involved there is actually done by machines, but there are still humans operating those machines because they have to exercise judgment, from a safety perspective, for instance. So similarly, we think that it's possible that in the future, most cognitive work that we do, putting things into a spreadsheet, for instance, or preparing a PowerPoint, a lot of these things will actually be automatable. However, it will not lead to removing humans from those workflows because a lot of our jobs will involve supervising AI systems and really specifying exactly what we want so that the AI system will get it right. And most importantly, and this is often not recognized, a lot of the judgment that we will have to exercise will involve some kind of normative or moral consideration that today, we might do without even really thinking about it. But in the future, that will be a much bigger part of what we do because the aspects of cognitive work that don't involve those moral considerations can be done much more quickly through AI systems. So exercising risk judgment, moral judgment, oversight, and supervision, translating between AI and human interfaces. These are all going to be aspects that will be more important for any worker, but especially for leaders, is our kind of educated guess on this.
And lastly, for the closing section, I think there are so many insights to gain from the essay itself. I would encourage our audience to read the essay and even the Japanese version, which we are collaborating with you on. And even in this dialogue, there were so many insights. There are a few things I want to ask, but let me club everything into one question. So we started with this concept of AI as a normal technology in this dialogue, and we are looping back to that again. I think the important thing is that it's a marathon, not a sprint, but it does not mean that we should lose speed as of now. So two-part question to you. One is, what should companies stop or start doing right now to consider AI as a normal technology without exaggerating or underplaying the impact? And the second part is, what should these companies do in the next 5 years to become equally equipped for the social readiness of AI as well?
Sure. I think companies should stop promising or believing that superintelligence is going to solve all of society's problems. So there are many tech leaders, especially in the US, who are promising that we're going to build AI that is far superior to human intelligence, and so that's going to cure cancer and maybe produce art that is better than any human can imagine, or really anything that you want. I think this is unfortunate in many ways. We go into great detail in the essay about why these superintelligence predictions rely on a misunderstanding of human intelligence. We think that while in certain domains like chess, where performance depends on really rapid calculation, you can expect these AI systems to become much more superhuman. This does not make any sense in a domain like medicine, where if you want to cure diseases, the bottleneck is not thinking really fast, but once you've come up with a candidate drug, for instance, to do clinical trials testing on thousands of people. And that's not something AI can do autonomously because we won't allow it to do so autonomously because of the incredible risks. So these are just pipe dreams. And I think it's unfortunate that so many AI leaders are making these false promises. I think companies deploying AI should stop believing those promises, because if you believe that superintelligence is going to solve all the problems, paradoxically, it takes away a lot of the urgency needed in order to do all the hard work. of deriving benefits from AI. So that connects back to something I was saying earlier, which is that in a way, the AI as normal technology worldview should give us more urgency to act on many of these much needed things. And ultimately, that's also my answer to balancing speed with social readiness over the next 5 years. We have to start with a realistic understanding of what AI can and cannot do, not so much because of its technical capabilities, but again, because of these moral reasons. AI cannot solve medicine because that relies on, medical experiments on human beings, which only humans should be able to do for ethical reasons. And therefore, businesses should come up with a clear understanding of which problems should be or can be solved using technology and which ones actually require institutional reform, societal adaptation, and those sorts of things. And that should be the starting point for balancing between speed and innovation.
Thank you so much, Professor. I think this idea of AI as normal technology, and as you rightly mentioned, it should be seen with urgency and not with the fact that we are downplaying AI. We should actually look at the real value that is provided by AI, how it can be integrated into the society, and I think that will be the key to successful and unsuccessful different use cases that emerge from now. So thank you so much for the dialogue today. I think we had a lot of insights today. We thank you on behalf of our team, and again, thank you very much for today's time.
Thank you.
Thank you.
Thank you. These were wonderful questions. I really enjoyed the conversation.